As I said just a second ago, good evening to everyone. I'm Matt Hall, Chair of the East Midlands branch. Very big welcome to you all. Thanks to you all for supporting our numerous different events throughout the year. If it's your first time at one of our events, welcome. Really hope you enjoy it. We do welcome the feedback at the end, which you will get a link to respond to. A massive thanks to all the committee that have been involved tonight and throughout the rest of the year. Your help's really appreciated. I hope you all enjoyed the session. I'll stop talking now, as it's Shailesh who's come to listen to, not myself, talking around entering confined spaces. So without further ado, I'll introduce Shailesh, and I'll speak to you all at the end, but just to wish you all a happy Christmas and a prosperous new year as well. Thanks for attending. We really appreciate it, and I hope you enjoy it very much, as I'm sure you will. Okay, over to you, Shailesh. Thank you.
Thank you very much. Welcome, everyone. Good evening, good afternoon, good morning, wherever you are in the world. This talk is about safe entry into confined spaces. So what are my objectives for tonight? My objectives for tonight are outline brief requirements of the confined space regulation in 1997. So this is applicable in the UK. But I suppose the same sort of requirements are there all over the world in the industrial nations where confined space entry is recognized as a hazard. My main purpose is to raise the awareness of the dangers from entry into confined spaces. The way I've structured this presentation is I'll start off with a confined space incident borrowed from Chemical Safety Board of USA, which is a very good site for process safety and general health and safety. And I would recommend that. In my references, I've put in links to these sites and the examples I shall be quoting. The third objective is to explain what makes a system for working in confined space safe, a safe system of work. And last but not the least, it's equally important to highlight emergency procedures related to confined spaces. So just to recap, brief requirements of the confined space regulations, awareness of dangers from entry into confined spaces, basis of establishing a safe system of work for entry into confined spaces, and to highlight the role played by emergency procedures and trained people. I cannot stress enough that all these four objectives relate to the safe entry into confined spaces. So I'm going to start off with a short video. It's about 12 minutes long from an actual accident related to confined spaces. And as you see this, watch this video, some of you might have seen that. Apologies if you've seen it before. It will be a refresher. I found it very enlightening, and I hope you do as well. So there we go. I'm going to start the video. Please let me know that you can see the full screen.
October 2nd, 2007. A terrible tragedy unfolded in the mountains 40 miles west of Denver, Colorado. 5 contract painters were trapped by a chemical fire deep inside a hydroelectric plant tunnel. The plant was owned by Xcel Energy, a major regional electric power company. The fire, involving combustible coatings and solvents inside the tunnel, blocked the only way out, an opening more than 1,400 feet away. There was no help available because the company did not have properly trained emergency responders standing by for such a rescue. For the workers, there was no escape. The Chemical Safety Board found that neither Xcel Energy nor its contractor, RPI Coating, had adequately evaluated the dangers of the work inside the tunnel.
The RPI contractors entered a confined space with highly flammable solvents, little training, and no emergency plan. From the moment they entered the tunnel, the stage was set for disaster.
Xcel Energy's Cabin Creek hydroelectric plant is located in a remote mountainous area approximately 6 miles from Georgetown, Colorado. A 4,000-foot tunnel, known in the industry as a penstock, was slightly inclined at the bottom and extremely steep at the top. The penstock carried water between the upper and lower reservoirs. At the bottom, water flowed through large turbines to generate electricity. Over the years, the penstock lining deteriorated. In 2007, Xcel Energy contracted with RPI, an industrial painting company, to recoat a large steel section of the penstock near the power plant and lower reservoir. Work began at the site in September. The penstock is a unique confined space that is difficult to enter and exit. Before the project began, a door was cut into the lower section to provide access for workers and their equipment. On the morning of the accident, October 2nd, RPI workers prepared to begin the coating operation by bringing approximately 10 gallons of a highly flammable solvent called methyl ethyl ketone, or MEK, into the penstock. Some of the solvent was used to clean the equipment and hoses before starting the work. Shortly after 1 p.m., 11 workers began coating a section of wall located more than 1,400 feet inside the penstock. To apply the new 2-part epoxy coating, workers used a specialized sprayer. Base and hardener were mixed and then sprayed onto the walls. But the workers immediately encountered problems. The epoxy was not adhering evenly to the surface. The workers flushed the hoses and spray wands with MEK each time a problem arose. But despite their efforts, they could not get the epoxy to adhere evenly. An RPI foreman decided to clean and remove the sprayer from the penstock. The crew began cleaning out all of the equipment and hoses using MEK. A worker brought in more of the flammable solvent to aid in the cleaning. Some workers noticed the strong odor of MEK as the vapor spread through the work area. At approximately 2 p.m., the vapor was ignited, most likely by static electricity inside one of the spraying machine hoppers. A flash fire erupted. Burning solvent burst from the hopper onto a nearby worker, catching his sleeve on fire. The flames spread quickly, engulfing the open buckets of MEK nearby. 5 workers were blocked from escaping the penstock by the intense fire. The trapped men shouted desperately for fire extinguishers, but there were none inside the penstock. Workers on the other side of the burning equipment ran the 1,400 feet to the entrance to locate fire extinguishers. One worker notified the control room operator to call 911. The 5 trapped workers could do nothing but wait and hope. Inside the penstock, the nearby buckets of epoxy and MEK burst into flames. The trapped men fled deeper into the penstock to escape the smoke. They used their radios to communicate with the workers outside, imploring them for help. Workers repeatedly attempted to fight the fire with portable extinguishers, but they were forced to turn back by the intense heat and thick black smoke. Inside the penstock, the workers continued to wait for rescue. At 2:11 p.m., county emergency personnel arrived at the site in response to the 911 call. But they had not been informed about the hazardous conditions within the penstock, and they were not equipped or trained to attempt such a technically demanding rescue. The trapped workers were instructed to move even deeper into the mountain, but they stopped when they reached the inclined section, which was too steep to climb. They told responders they were struggling to breathe as smoke filled the penstock. Some of the responders entered the penstock on an all-terrain vehicle, but the dense smoke blocked their path, and they had to retreat after just 200 feet. The responders then drove up the winding road that rose over 1,000 feet to the upper reservoir. There, they lowered air bottles and respirators through a small hatch, hoping these would reach the trapped workers below. Finally, at 3:40 p.m., A specialized rescue unit arrived from Denver, some 40 miles to the east. A short time later, a specialized mine rescue unit arrived. The teams prepared for entry, but it was too late. The 5 workers inside the penstock had died of smoke inhalation over an hour earlier. The following day, responders found their bodies near the bottles of air. The CSB found that the accident at Excel's Cabin Creek plant highlights 3 key safety issues: the lack of regulatory limits for bringing flammable materials into permit-required confined spaces, Xcel Energy's flawed process for contractor selection and oversight, and the lack of preparation for possible emergencies.
Confined space technical rescue poses many unique challenges for us as emergency responders.
Captain Steve Azeltine is the Division Chief of Training for the West Metro Fire and Rescue District in Denver. He and his team responded to the accident at Xcel Energy.
A confined space is not meant for continuous human occupancy. It has a small ingress and egress point. A permit-required confined space is any area that can have an atmosphere that's immediately dangerous to life or health. You're required to have a rescue team on site and professionals there to help you in a permit-required confined space, and most times we see people just blow that off. And unfortunately, those are the people that don't get to go home.
There was 45 minutes between the incident and when the last radio conversations occurred with the workers inside the penstock. That's a significant amount of time.
The fact that there was 45 minutes before the last radio communication tells us that there probably would have been enough time had an emergency responding group been there and been prepared to handle the chemicals inside, to potentially put it out and rescue the individuals.
The nearest community emergency responders trained for confined space technical rescue were located over an hour's drive away.
The fire department in your local area may not have a confined space technical rescue team. They may not have that specialized level of training. They may have to wait for that kind of response. And if you're the person down in there that is in a low oxygen environment, you don't have time to wait.
To increase the availability of such specialized responders, the CSB recommended that the state of Colorado develop a new firefighter training certification program for confined space rescue. The CSB determined that when Xcel Energy was selecting a contractor to recoat the penstock, RPI did not have an acceptable safety record based on Xcel's own evaluation standards.
In the safety category, RPI was evaluated to have a 0 on a scale of 0 to 5. And that was the lowest possible rating. However, that did not prevent RPI from winning the competitive bidding process, largely based on low price.
Xcel officials determined that another coating contractor had better technical qualifications than RPI. However, that company's estimated cost was higher than Xcel's budget for the project.
Xcel didn't consider safety to be one of the criteria by which RPI could be disqualified.
Xcel did plan to closely monitor RPI's safety performance during the project. However, the CSB determined that Xcel's oversight of RPI remained inadequate. The CSB recommended that the Colorado Public Utilities Commission develop rules governing the selection and disqualification of contractors based on their safety records. The board also urged the commission to require regulated utilities to investigate and report to the public on all serious accidents. In 1993, OSHA issued a regulatory standard for permit-required confined spaces in general industry. But the Chemical Safety Board identified 53 serious accidents since 1993, where flammable atmospheres led to fires or explosions inside confined spaces. These accidents caused a total of 45 fatalities and 54 injuries. Most of the fatalities and injuries have occurred since 2001. Existing good practice guidelines recommend against working in any confined space where the concentration of flammable vapor exceeds a specific low percentage of the lower explosive limit. That is the lowest concentration of a flammable vapor in air that can burn when ignited. Concentrations below the lower explosive limit, or LEL, are too lean to burn. Concentrations exceeding the upper explosive limit are too rich to burn. Overseas regulations, as well as certain OSHA standards, including the OSHA standard for shipyards, prohibit work inside a confined space if the atmosphere exceeds 10% of the lower explosive limit. However, the OSHA General Industry Standard, which regulates over 4 million permit-required confined spaces across the country, sets no such safety limit. The Chemical Safety Board believes that the limit must be set conservatively because atmospheres can change quickly. Although monitoring is essential, it may not always reveal the full extent of the hazard.
If you don't establish limits, how are workers to know what is safe and what isn't? And it undermines the importance and the recognition of those hazards of a flammable atmosphere.
In its final report, the board called on OSHA to amend the permit-required confined spaces rule for general industry to prohibit entry and occupancy if the atmosphere exceeds a specified low percentage of the LEL.
The incident at Cabin Creek will affect me for the rest of my career. Do I hope that that never happens again? Absolutely nobody ever wants to see this type of incident occur, and anything we can do to help prevent that, I think, is invaluable.
Often companies do not properly consider the dangers of working within the unique environment of a confined space. Companies and contractors need to be diligent about assessing those hazards, controlling the risks, and planning for possible emergencies. We hope that our investigation and this video will help prevent similar accidents in the future.
For more information about the CSB investigation of the accident at Xcel Energy, please visit csb.gov.
So that was quite a serious video to watch. It brings home the point that confined spaces are quite unique hazard possessing entities. Although the video is based on American occupational health and safety standards, they call confined space permit required confined spaces. For us in the UK and also most part of the Europe, it is the Confined Space Regulation 1997. Although the names are different, the regulations all agree that confined spaces are very, very hazardous areas. So I'll start off with some definitions. In the regulations, confined space is any place, including chamber, tank, vat, silo, pit. Now you might think pit is open at the top. Should it be confined space? But yeah. Why? And continuing that, trench, pipe, sewer, flue, well, or other similar space, the key point here is there arises reasonably foreseeable specified risks. So you might ask, what is this foreseeable specified risk? So here are some definitions. Specified risk, which is reasonably foreseeable under the regulations, is risk of serious injury to any person at work arising from fire or explosion, loss of consciousness arising from increase in body temperature. So if you think about workplaces such as bakeries, where if a conveyor belt has broken down and there's production pressure to fix that, and the maintenance people do have to go into the oven, there would be standards, there would be limits on below which it is safe to enter. And unfortunately, there was an incident a few years ago in Leicester where maintenance staff was killed because they went in and the body temperature increased because of production pressures. And this is something which is a common story across all industries. Production pressures, production must never cease, especially in a continuous environment. So as fellow safety professionals, is my appeal to you, please, please, please do not let production pressures cut corners when it comes to confined spaces. So that's body temperature. Further definitions: because of lack of oxygen, because of fume, vapor, and free-flowing solids. As part of my presentation in the end, I've given you about 9 categories of actual confined space accidents and incidents on different categories where lack of oxygen, entry into grain silos, might be sugar, which is sweet and something everyone probably likes, but it can suffocate people in the tank if it's not controlled, and free flowing solids. Drowning, that's also very common. I know of an incident where a tank was supposed to be isolated and workmen entered the tank for some maintenance tasks, and someone activated a valve and the wrong valve, and the whole solvent went into the tank, drowning the person. Horrible way. I'm not trying to sort of drive home the point of accidents. It's just to sort of highlight in extreme cases how serious unsafe entry into confined spaces can be. So under the regulations, a competent person is someone with sufficient experience of and familiarity with process, plant, equipment, and knowledge of regulations. So it does not necessarily have to be the health and safety manager, or officer, or director. It's a person who is defined under the regulations, having experience, is familiar with both process, plant, equipment, and knowledge of regulations. So now we'll just go through a few highlights of the regulations, then we move on to the safety part and emergency arrangements. So highlight of the regulations. So in the regulation, the word used is must, and my fellow professionals who are full-time or part-time health and safety officers, we know that the regulation, if they use words like must, then the concept of cost versus risk does not come. Must means must. There's no reasonable or arguing against costs, etc. So employer must, it's mandatory to employ compliance with regulations. So what are the regulations? Competent person must carry out a risk assessment. We defined competent person in the previous slide. Prevent where possible need for entry. So this is, if you look at your control hierarchy for risk assessment, the top one is, do you need to carry out entry? So that's the question person who is going to authorize confined spaces ask. Do you need to enter? There might be several options, such as, and I'll quote the examples later on. Establish safe working in confined spaces. So a safe system of work. How do you define a safe system of work? A system of work, safe system of work, is where hardware, software, and liveware must work with each other. All three must work independently and in conjunction with each other. So what's the hardware? So if you take a confined space, the hardware could be the equipment, tools that you take in. Software could be your written permit to work system, and your liveware is the attitude, the skills of the workman. So always think of these three things when you're looking at a safe system of work. It can be broken down into hardware, liveware, and software. Another common example I could quote is like driving a car. If you're driving a car, your hardware is your car, Your software are the driving regulations that you will stop at a QA, you will stop at a red light. And your liveware is you, the person. Are you tired? Are you fully qualified to drive? These are, what is your attitude? If someone sort of cuts in, do you actually rush after them and try to teach them a lesson? Or do you just take it in your stride and say, okay, if he's cut me in, so be it. I'm not going to behave silly billy. Yeah. So these are the three things: liveware, software, and hardware. Again, the regulation stress is not nice to have. You must formulate emergency procedures and you must implement them should an emergency arise. Plant and equipment requirements for safe and easy access, easy egress, suitability. For example, if you are coating a tank, a bulk tank, which used to contain, say, flammable items, then if you take an inspection lamp inside, it has to be flame proof. You can't take an ordinary car inspection lamp in there. There was an accident many years ago where people were inside a tank. They were repairing fiber coating and they were using, again, acetone, a very flammable solvent. And they had a normal car inspection lamp inside, not a flame proof one, because they needed the light. And unfortunately, that lamp broke and that actually caused the explosion inside the tank, killing people. This was in UK, not USA or anywhere else. This is in our UK. So what is this wonderful risk assessment process which the competent person has to carry out? Well, the first question, as I said, do you really need to enter confined space? CS stands for confined space. Can you use appropriate tools for sampling, cleaning, or testing from outside? It might be possible. Do you have to, for example, do you have to clean or remove residues using water jetting? Can you do that? Or steam? Or do you have to use chemical? Or use in situ cleaning devices? I used to work in the paint industry, and when a paint batch was made and we had to change the color, we had in situ cleaning devices, which would prevent someone having to go in and clean the sides of the vessel, reacting vessel or the paint manufacturing vessel. These were spray nozzles which would clean down the sides once the paint was made. So there was no need for anyone to go in. So in your own individual workplaces, ask yourself these questions, especially if you are the competent person or person who is responsible for managing safety in a confined space. Go through this checklist. Please, please do that. Can you see what's happening inside by cameras, sight glass on a vessel, or CCTV? Some underground workplaces, such as sewers, etc., they do have cameras in there and they can monitor persons working inside. So that is what I'm seeing. So when you consider risk assessment, you look at these things. So now we talk about the hazards. And I suppose everyone knows the hazard, difference between hazard and risk. Hazard is something inherent. You can't take it away. Risk is the chance that the hazard will occur. At 100% risk, the hazard is realized. So hazards, typical hazards, this is not a complete list, but these are the typical ones which we come across in everyday life. Flammable substances, as we show in that CSB video. Oxygen enrichment. Now there is a case study in my reference list, which I provided at the end of the list. I've given reference to Swan Hunters shipbuilding, where there was too much oxygen. It led to a fatality inside a ship, which was being refurbished or being built. And this is very common, toxic and or corrosive gas, fume, vapors, or residues. So when you see a tank and it looks clean inside, you need to check what are the residues. And that also should prompt an action. How am I going to get rid of these residues? If I'm going to get rid of residues using some chemical, will it react with the residues and produce a toxic vapor as a reaction product? Many times inside a bulk tank, confined space, if you're going in to clean out the residues, you do need to be aware that residues might be looking dry at the top, but they might not be dry. They might be full of solvent underneath the dried skin. And then that will make it a flammable atmosphere, even though it's normally looking very dry. So you do need to know these things. Lack of oxygen, that is also a big killer. Especially, I used to work in the pipeline industry. So in a pipeline, and these are the big pipes, say 3-4 meters in diameters, conveying underground chemicals and fuels, etc. Before cleaning out the pipelines, the normal practice is if you're doing any hot work inside these pipelines, which are sort of confined spaces, it's very common to use something like nitrogen to displace the oxygen so that when you do the hot work, there is less danger of vapor explosion fumes. But there, once you've done the work, you need to remember nitrogen is a heavier gas. It might be sitting in there, and there might not be enough oxygen. So if someone has to go in following the pipeline cleaning or work inspection, they need to make sure they carry oxygen with them. And again, in my references, in the case study, which I'll give you as homework at the end of this session, there is a nitrogen accident. I'll show you first couple of minutes to introduce the scene, and then I'll stop the video, and then following slide gives you the question to consider. So please don't cheat and look at the whole report because I've given you the answer as well. All right. Ingress of presence of liquids. These are the typical hazards, remember. Free-flowing powder material. So this is very true in the bulk silo containing grains. So if you think of a beer factory, which is storing barley in bulk, and if you have to go in there, ensure that no way can the bulk store from somewhere else flow in and suffocate the person working inside these tanks as confined spaces. Excessive heat, hypothermia, or dehydration. Again, this is the one I mentioned earlier about the bakery incident in Leicester in UK, where there was excessive heat left, residual heat in the oven. It should have been allowed to be cooled down before anyone would enter that. This is also very true, especially if you look at a manhole on a street and the workmen have to go in to do whatever is necessary. They have to think, can they fall? Or can something fall from open access at the top? And if you are inside a bulk tank, say 10 meters tall and 5 meters wide, and you have to say install a new level sensor, a safety mechanism at say near the top, how will you reach that? What will you use? What sort of, if you're using a ladder, how is it going to be secured? When you're working there, are you going to drop something if anyone else is working down below you? Or if you are not using access equipment, secure access, harness, etc., is there a danger of you falling down, etc.? This is again very typical when you're working in a confined space, which is not the normal size of space. So now I'm setting out the steps to do a risk assessment. So I'll outline the hazards. So here are some of the factors which will be important. What did it contain? So if say you are a contractor who specializes in confined space entry and cleaning, etc., for third parties, it's very important to ask the question, what did this confined space contain? Whether it's a tank or a pit or a silo, what did it contain? Can we have the safety data sheets? Please ask for those things. Are there any residues? How best to clean them? And again, you can ask the company, if it's not your own company, what are these residues? What's the physical state? Can it have more than one substance in it? Does it react dangerously with something? Yeah. Can the work I'm doing contaminate the residues? Is there oxygen too little or too much? So these are the factors you must consider and take appropriate countermeasures. What are the physical dimensions? What are the hazards from actual work? Cleaning chemicals. Am I taking in any source of ignition, such as non-sparking tools in a flammable containing residues in the tank? And this is important as part of your permit to work. Isolation to prevent danger from substances accidentally entering, especially if it's a big premise and the confined space that you're working on is part of a semi-automated plant, and the control room operator is sitting far away. They can't physically see you. Are they going to accidentally start something that will affect you? Mechanical moving parts, hydraulic energy that is hidden. We are pretty familiar with mechanical, electricity and mechanical parts. But if something if something has hydraulic energy, do you dissipate the energy? How do you make sure that hydraulic energy not suddenly supplied to someone working in a confined space? And then kinetic energy is something that can fall from the top. This is absolutely essential requirement for emergency. So you need to, in your risk assessment, consider what different type of emergencies the people working in the confined space are likely to face and provide appropriate emergency measures. So I'm repeating some of things myself because they are so important that I feel they need to be repeated. So you might find some duplication, but that is intentional. Supervision. Don't leave them on their own, or they know what they're doing. They've been doing this for last 30 years. I can trust them. Famous last words. Supervision must be provided and must be adequate. Competent. As we've seen in the starting video from CSB, the competence of the people who were asked to paint the inside of the tunnel was questionable, but they were still, because they were less expensive. So when you choose contractors or when you send your own people in, make sure they've had the training, they understand the hazards, understand the risk assessment, they understand the emergency measures to follow. That is competence. How do you communicate? One of the things is, if you're taking communication equipment in an area which is subject to DOSIER regulations, danger substances and explosive atmosphere regulations, meaning there is a possibility of fire or explosion. The communication equipment you take in there, if it's a radio, it's got to be appropriately EX rated so that it doesn't provide a source of ignition. Think so minutely. How will you make sure that you're monitoring the atmosphere? Say people have gone in, and when they went in, the atmosphere was fine. There was sufficient oxygen. There was no sulfur dioxide or H2S or carbon monoxide or carbon dioxide, nitrogen. Oxygen level was appropriate. But then this has to be continuous. You don't just test it once and allow people to go in. You need to find a means of continuous monitoring when it is occupied. Gas purging. So yeah, if it contains a toxic gases such as hydrogen sulfide or say isocyanates, you purge it in another gas to make sure that none of the toxicity or corrosive atmosphere is there. But then you also check it, double check it. Belts and braces approach where confined space is concerned. Ventilation. So when I was working in the paint industry, this was a question which came up. We were asked to supply, say, solvent-based coating to, say, places like the refineries, where they had to sort of reline the epoxy coating because the tank used to contain flammable materials or corrosive and materials which would attack the tank coating. So when we supplied the coating, we were asked and we provided the rate of ventilation depending on the tank size so that there was sufficient change of air so as to be continuously below the load explosive limits. And this we have seen in the video I showed you from the Chemical Safety Board, CSB, is essential. So if you are in the business of recoating your, say, vessels, reaction vessels, or your tanks, bulk tanks, etc., with any flammable, say, solvent-based coatings, do ask their technical person to provide you with this data. They have this data. Most reputed paint companies will have this data, and that will tell you if you provide such and such rate of ventilation, you are not likely to reach lower exposure limits. No one can be certain for 100%, but this is a good starting point. What is your ventilation rate to keep flammables below, or for that matter, toxics below? A safe system of work will also consider, is it likely to be hot, cold? Will people work there be dehydrated whilst they are there because of the working conditions? If that's the case, then you limit their time in the confined space. That's a very good control measure. You say you will be there for, say, 2 hours, and then you must come out, and you'll be replaced with someone else who will be there for 2 hours and then come out. Yeah, that's one way of controlling. Further, safe systems of work, isolation from source of energy. I'm repeating myself because this is so important. You not just think of electrical, I've knocked the electrical supply off and I've taken the fuses out, etc. Will it remain isolated? Have you communicated that to other people who are not going into the confined space so nobody accidentally starts it up? Important. Selection and use of suitable equipment. As I said, if you're going in a flammable atmosphere, make sure all the tools, any lighting equipment you take are spark-proof and protected, suitable for that atmosphere. Removal of residues. How will you do this? Who will do this? If you are using any chemicals, will it react with the residues? All these questions are very, very important. Isolation of gases, liquids, and solids. So the first point was energy, and second point is about material. PPE and RPE. So just bear with me. Yeah, PPE stands for personal protective equipment, and RPE stands for respiratory protective equipment. There's very good guidance on RPE and PPE selection from Health and Safety Executive. If you've not seen that before, please do refer to it, make a note to look it up. It actually specifies different types of respiratory protection, masks, half masks, full face respirators, etc. It gives you the assigned protection factors, which is a guidance to its selection and use. And again, these are also subject to fit testing. They're also subject to maintenance. If you do have to take portable gas cylinders and internal combustion engines inside for your work in a confined space, you have to make sure that they are suitable for the workplace. If we're supplying gas by pipes and hoses, what's the flow rate? And are the pipes and hoses safe? Can you control the flow? Can you shut it off immediately if there's an emergency? Access and egress. How are you going to get down in a trench? And if there's an emergency, how are you going to get back up? Will you have to wear a harness? And will there be someone watching that person? If he or she gets into a difficulty, can he or she be winched up very quickly? If there's an emergency, how will you come out? How will you exit safely? Is your exit protected if there's a fire? These are very important questions when you're working in a confined space. How will you prevent fire? And many times it's usual practice, I think nowadays, there'll be a fire watch person along with the emergency queue. So fire prevention means if there's a little spark and a little fire starts, it's put out with suitable fire extinguishers. What sort of lighting do you require? Have you thought about that? Is the confined space that you're entering fully lit? Is it partly lit? And what sort of lighting is there? Is it an incandescent bulb or is it an LED? What is it? Is it suitable? Static is a hidden one. And we've seen that video. Static was one of the likely. It wasn't said for definite, but they did say static might have been produced when they're spraying, because when you're spraying, especially the fine particles of solvent, they produce a lot of static. And that is a typical source of ignition in a flammable atmosphere. There should be no smoking inside. And what are your rescue arrangements? Have you anticipated different types of emergencies, and have you got the right equipment and the rightly trained people? These are all parts of safe system work. And one of the methods I mentioned previously is limit working time within this confined space if it's particularly hazardous confined space. So typical precautions: special access equipment, special protective clothing and equipment, respiratory protective equipment, including breathing apparatus, specially designed work tools, for example, non-sparking, lighting, additional ventilation, methods of communication, first aid provision. These must be present when you send people into a confined space. So permit to work system is like a safe system of work. The essential elements are, it's a formal, it's not just a piece of paper. Many people, because they write so many permits, take it, oh, it's just a formality. Nobody's bothered. But no, it's a formal written, it should be a living document. If anything within it changes, work must be stopped and reassessed. So it's used where there is a reasonably foreseeable risk of serious injury. So see, that ties in straight away with the legal definition of a confined space, where there's a specified foreseeable risk of injury. A permit to work will set out work to be done and precautions to be taken. It's a formal record that you've done a good risk assessment. It's a kind of a risk assessment. You looked at foreseeable hazards, risks has been considered in advance, and all appropriate precautions were taken in a correct sequence. It must identify the confined space. It describes the work to be done, right down to a T. Time limits of start and finish of the entry. Results of gas taking. So if you are doing any monitoring, what was it when you went in? If you're doing continuous monitoring, what is it? What was it when you finished work, etc. When you hand over the confined space back to the production unit. What was isolated? Mechanical, hydraulic, electrical, etc. So all these things should be part of your permit to work system. A record of ventilation. So if you provided any external ventilation or gas purging, what was used, at what rate was it used? Why was it used at that rate and not higher or lower? You should be able to justify that. And importantly, personal protective equipment and respiratory protective equipment required. And it's the work of the supervisor who is going to monitor the confined space work to ensure that all these precautions identified in permit to work are actually in place. It's not just a piece of paper. I will stress that again and again. Restriction of working methods, confirmation that emergency equipment people are available, authorization from permit issuer. So usually it's the site manager or the site foreman or the site engineer who will issue the permit. They must authorize it. And acceptance, so the permit acceptor, the people who are entering the confined space, they have a duty as well to accept the permit, understand the permit, and make sure they adhere to the permit, because sometimes they might not be familiar with the area, especially if it's a third-party contractor. They need to make sure that they read the permit to work, safe system of work, and accept it. And then very important, once the work has been completed, everything should be restored as it was and confirm that the work has been completed. Ensure that whoever is isolated the plant or power must be the same person to restore connection. So if the work is going across shifts, and again, there should be suitable handover mechanism, because this is a safety critical communication, isolation on and off, and cancellation of the permit. Very important sign off. So what are these emergency arrangements we are talking about? So these must be made before, not once an emergency starts. Very important. Before someone is sent into confined space, you must make your emergency arrangements. So what are these emergency arrangements? So these must be made to reduce risks to so far as is reasonably practicable. So these arrangements should be proportional to the risk, in other words. Emergency arrangements, ES, must consider all stages of plant work, cleaning, access, egress. It's not just access, it's also how will they come out? What happens in an emergency? Do they have sufficient capacity to rescue people who are gone in? And most importantly, there must be rehearsals, there must be appropriate training for everyone who is part of the emergency arrangement team to be trained. Emergency arrangements involve providing and maintaining resuscitation equipment where necessary, especially if it deals with toxic corrosive gases. If person working inside is wearing RPA, which has come off and have sort of gone unconscious, how will you bring them back safely? Also, the regulations actually say that emergency arrangements must be put into action immediately when necessary. You don't ask your boss, shall I put this emergency? You react on it straight away if you're an emergency, part of the emergency arrangement team. It needs to cover rescue and resuscitation equipment. So equipment must be up to date, maintained, and ready to go. How will you raise the alarm? Do you need to raise the alarm to the local fire brigade or the emergency services, the hospital, etc.? How will you do that? Because you might be on a remote site, a confined space area. Will you use a phone? Will you go to call 999? Consider all these factors and write them down. And also important to safeguard the rescuers. We have heard of unfortunate incidents where the fire brigade personnel have gone into a fire and they themselves have been grabbed. So in your part of emergency arrangements, you should also make arrangements. If anyone is going in to rescue the personnel who are in trouble, how will you make sure that they are also made safe? Fire safety, yeah. Control of plant. So plant must be totally isolated. And any first aid for minor injuries. Is there a trained first aider part of the emergency arrangement? So emergency services, you should know what is the response time. Are they familiar with your site, access and egress? So do talk to your local emergency services. Run a test scenario, internal emergency. Those who are subject to coma, upper tier regulations, they will have involvement from their local emergency service every 3 years. They have to do a scenario. But if you are a small and medium enterprise, you're not subject to say coma regulation, it still is good practice to let your local emergency responders come to your site, understand where flammable, toxic, corrosive chemicals are, where is the supply of gas to your line, to your site. How can you turn it off in an emergency? They should know that as well. Train everyone who is involved in emergency arrangements. So I'm going to we are nearly to the end of our session, 3 minutes in. This is the work I would like you to take it as homework. I'll start off the scenario. The answer is there, so I will not run the whole video. Please try and see if you can note these things down after watching 2 minutes of the video and do it for yourself when time permits. And then you can look up the answer. The full report is there, which outlines what the finding was and how they recommend to prevent it from future. So I'm just going to run this for first couple of minutes to set the scene. This is about oxygen deficiency, nitrogen asphyxiation.
Workers who have survived these episodes describe a funny feeling where they can take a deep breath and yet they still feel like they're suffocating.
On November 5th, 2005, 2 workers died at the Valero Energy Corporation refinery in Delaware City, Delaware. They had entered a reactor vessel, a confined space that was filled with nitrogen, an odorless, invisible gas. The accident occurred during a maintenance operation at the 5,000-acre facility, which processes 180,000 barrels of crude oil per day. The complex is one of Valero's 18 U.S. refineries and has 570 employees. The U.S. Chemical Safety Board investigated the accident and issued a case study with safety recommendations.
This is not a new issue for the CSB. In fact, the board conducted an earlier investigation into the hazards of nitrogen asphyxiation and issued a safety bulletin in 2003. The bulletin identified 85 nitrogen asphyxiation incidents that occurred between 1992 and 2002, killing 80 people and injuring 50.
I'm going to stop this here, but this is the case study. Watch the video, say few minutes into that. Don't watch the recommendation conclusions. And then if I go back the previous slides, see if you were the consultant employed by this company before the accident, how would you advise the company? So in other words, write down a safe system of work, what PPE, what access, what egress, what emergency arrangements. This will be a good practice to reinforce the points I've made. So now, to summarize, confined space entry is a high risk activity and should only be undertaken as a last resort by trained personnel. So think of the control hierarchy. Can you avoid entering confined space? That's the most critical question. And answer will be no, you can't. You have to go in to do the work required, but then follow all the safe system. So risk assessment must be completed prior, not while the people are in there and, oh hell, I didn't do a risk assessment. Permit to work is a safe system of work to minimize hazard from entering into confined space. So I'm going to stop here, but before I do that, take any questions. I'm just going to show you the rest of the presentation, which I'll be sharing with IOSH, and it will reach you. These are the references I've given you. So L101 is the control of confined space regulations guidance. The second one is a case law where there was too much oxygen and the contractor's persons died. HSG 250 and HSG 253 are very good guides. The next one is the OSHA standard, if anyone is watching from the States, that actually talks about permit to work, confined space, etc. The last one is an article I wrote a few years ago for Health and Safety International magazine on confined space. The link will take you there. And as I promised, this I'm going to leave for now, but you will get a copy of this. I'll just give you this. I've made an artificial intelligence video, and obviously I didn't pay the money to get it made because I'm a retired person and they wanted a full year subscription. So, but why I have to put this in? It is to do you think about using artificial intelligence very carefully. Obviously you are the subject matter expert. Don't let it tell you what to do. But this is what you can do as in-house training material. I'll just play a couple of 30 seconds.
You know, I've worked a lot of dirty jobs. I've learned the hard way that safety isn't just a good idea, it's the only idea. This is especially true when you're dealing with confined spaces. Think about it, these are places that can be dangerous, even deadly, if you don't know what you're doing. We're talking about tanks, manholes, tunnels, the insides of machines, places with limited access, poor ventilation, and maybe even some nasty surprises lurking inside. One wrong move, one whiff of bad air, and things can go south real fast.
Okay, so that's just a taster for you. I made this using ChatGPT and AI video, which is available for free. In video is the name of the site. You could write your script and input into this to make a little training video. If you don't mind their captions, to stop that, it will require you to take out a subscription. So if you're a small company, maybe you wouldn't consider that. If you're a medium-sized company, it's a good way to go to make your own. Because if you make this training video, safety video, you know your site better than any outside person. And you can do quite a reasonable, good job. Of course, you have to sense check it. Okay, so here's a list, as I said. I've given you silo and grain bin accidents. These are from the internet. Sewer and manhole accidents, mining disasters, industrial tank and vessel accidents, oil and gas sector, shipbuilding, utility and maintenance work, other notable ones, Mexico, Ghana, etc. So I have stopped here now. I hope you enjoyed the presentation, and I look forward to your critical feedback. It's such a vast subject, but I've tried to do some justice to it. Thank you very much.
I'm saying we've got a couple of questions that have popped up in the chat. I don't know if you've got the time to answer
Sure.
some questions.
Sure.
One
What's
of
the
them was about what training would be recommended for confined space competent person to complete. It's been recommended in the chat, the City and Guild management of confined spaces, but didn't know
Yeah.
if you had any awareness of any other recommended courses.
I was also considering Draeger. They are the breathing apparatus, air systems, RP suppliers, Draeger Safety. They do confined. And if you look up in Google confined space training, there are some equally good big suppliers of the training. It should be proportional to the risks you have on your site. So if you're dealing with toxics, corrosives, inflammables, and confined space is something which is routine, then I would suggest you go with a reputed company. Personally, I have not undertaken any training, but I have recommended greater safety to my employers in the past.
Yeah, and this next question is quite a specialist question. So
Mhm.
it's about we've got any knowledge on what fire extinguishers can be used within a confined space. There's some conversation in chat suggesting whether we should avoid CO2 or dry powder in confined spaces due to the asphyxiation risks.
If the confined space is large enough and you use a CO2 cylinder because of the nature of the risks there, if it's a flammable substance and you're going to use a foam to smother access to oxygen, then that should be fine. If the confined space is really confined and not very big, then yeah, I would avoid fire extinguishers. If the confined space is large enough, then a fire extinguisher is not going to break down oxygen to very low levels. And in any way, in such a situation, if you're using gas monitoring, you would know how much oxygen is there. Don't think it is quite a specific situation. So depending on the size and the nature of the confined space, you take fire safety precautions. But for a huge tank where there's no flammable atmosphere, I have seen fire extinguishers being used because say they're doing some hot work, cutting, grinding, etc., and a little fire starts in a little section of residue. Fire extinguisher was quite handy there. It was put out with using a foam extinguisher. I've seen that happen in one of my workplaces. Yeah.
Right, yeah. Thank you very much for that. Yeah, apart from that, I think the only other questions I can see is about getting access to the recording. So I believe the recording and the slides will be shared.
Yeah, I shall be passing them on to IOSH, and I think network team, Ellie will be doing that. Ellie?
Hi, yeah, if you just pass it on, I'm sure Liz can organise to get the copy sent out to all you guys.
Okay.
So yeah, apart from that, thank you very much, Shailis, and thank you everyone for attending.
Thank everyone for your time, especially in the evening. It's precious time away from the family, but I hope it gave you some new things to learn about. And I do recommend you do the case study that I provided. without cheating, of course.
Okay, thank you very much, Shailesh, for that. Really enjoyed it myself. I'm sure everyone else did. Thanks for your time. Thank you everyone for attending. I hope you enjoyed it, and please do give us some feedback when you receive the link at the end of the session. Thank you everyone, much appreciated. Take care and enjoy the rest of your evening. Thank you.
Okay, bye.
Thanks, Shailesh, much appreciated.